We're live at iCarly, huh? Here we go. So, Dave, what we're going to do is learn how to we're factoring cubic polynomials, okay? This is brand new. This is stuff you haven't seen before, okay? Factoring cubic polynomials.
What?
2, 15, 18, okay? We're going to be factoring cubic polynomials, okay? Now, if you see, this is totally different on the side, okay? Totally different on the side than x plus 2 cubed, okay? Really quick, before I do anything, do you see the difference?
Hold on.
I want you to be able to see the difference. This is x plus 2 times x plus 2 times x plus 2. This would be a big FOIL problem, right?
Yeah.
This is not. This is a factoring problem, all right? So the way you factor a perfect cube is this. You've got a little formula, and the formula is going to help quite a bit. If you have a cube plus a cube, our formula is take it and rewrite it as parentheses a plus b, a squared minus ab plus b squared. So first of all, in this example, we have x's and 8's. We don't have a's and b's, but we can make it kind of into a's and b's. So what I know is that, and I'm going to write it in an odd way, but this is the same thing as an x cubed plus a 2 cubed. I'm just going to rewrite it as an x cubed plus 2 cubed, just to show you that my x would represent the a's up here, and my 2's would represent the b's up here. So I have a cube. I do have a cube plus a cube. Okay, 2 cubed is 8, right? So all I know, once I get this written, all I have to do is just put the x and the 2 in the right places. That's all I have to do. X would represent the values of a, and the 2 would represent the values of b. This is actually pretty easy. So the answer is simply going to be a x plus 2, because the x represents the a, and the 2 represents the b, times a squared, which in this case is x squared, plus, whoops, sorry, my bad, minus, look at the formula, a and b, which would be a 2x, plus b squared, which is plus 2 squared, which is plus 4.
Would it be minus or plus?
It is minus. It is minus, and it's minus from the formula, right?
I did not understand that.
Okay, let me do it again, okay? Okay, thank you, Avi, for saying that. Let me do it another way, okay? So, let's do it another way, okay? So, we're looking for a perfect cube plus perfect cube. So, I know that 2 cubed is 8. So, what I'm doing is I'm letting a equal my x. I'm letting my b equal my 2. Because I have a x cubed plus a 2 cubed, right?
I did that before. Wait,
Hold on, shh, hold on. I'm going to do my best. Okay, so Abe, you want to plug them into this formula, right?
Yeah, I got it.
You got it? Right. And the 4, you know I got the 4 from? B it's b squared, so it's 2 squared.
Yeah, I didn't understand that the A and B were plugged in.
Let me do the next one, and I'll do the next one the same way, okay? So the next one, if I rewrite this as a 2x cubed minus a 3 cubed, okay? Because 27 really is 3 times 3 times 3, right? And 2x times 2x times 2x is really a 2x cubed, right? So let me write down the a and b, and I think that'll help you a whole lot. So I'm going to let a equal 2x. Thanks, Katie. I'm going to let a equal to 2x, and then the b represents the 3, okay? So it's a slightly different formula. It's almost the same thing. The only difference is the signs because of the negative. This one goes minus plus plus instead of the other one was plus minus plus. So what we do is this. Our a is going to be 2x. So I'm going to put 2x where I see the a's, and my 3 represents the b's. So I'll put in the 3's where the b is. So let's put it in the formula. So the formula is this. Instead of a minus b, a is 2x, so I'm going to go a 2x minus 3, right?
where'd you get the 2x?
Great. So I rewrote this 8x cubed as a 2x cubed because I know 2 times 2 times 2 is 8, Renee? And I know obviously x times x, right? So this represents my a, my value of a, and this represents the value of my b, okay? So I'm just plugging those values into my formula, okay? So then parentheses, I need an a squared, so I'm going to square this. I'm going to square this, which gives me a 4x squared, plus ab, which is these two, right? If I multiply these two, I get a 6x plus a 6x. And then plus b squared, so b is 3, b squared is 9, plus 9. You here or you here? Good.
I'm like 100% confused.
Okay, let's do the next one. Hopefully I'm going to get you on the next one, okay? Okay, shift it over. You guys ready to shift over? Okay. Now, this one isn't a perfect cube, but this one needs to be common factored first, okay? It's not ready to go yet. We got to fix it. So what I'm going to do first is common factor out an 5 and an x, because that's what they have in common, right? So if I common factor out of 5x, I'd have a x cubed plus an 8. Okay, so now, Renee, you with me? What I need a cube plus a cube. And that is x cubed, right? Plus I need a cube here. What number cubed? What number cubed would make 8? Perfect. So let's rewrite it. Keep 5x there. X cubed plus 2 cubed, right? Great. Now I'm going to slide this up for a little bit and look at our formula, okay? So our formula says if we have a cube plus a cube, if we have a cube plus a cube, we can rewrite it in this factored form, right? So in this case, I have a cube plus a cube. I'm going to let a equal the x. So it's a cubed, and I'll let the b equal the 2, right? Because I need my a cubed plus my b cubed, right? So if that's the case, keeping the 5x there, okay, the formula says, let me slide it down just a second. Here's my formula, okay? It says, I'm going to take a plus b, so x plus 2, parentheses, x plus 2, times, I need a squared, well, a is x, so x squared, right? Minus ab, well, ab would be minus my 2x, plus my b squared, but we let b be 2, so plus 2 squared, which is 4. And that's the answer. Okay? So the trick is we need to make a perfect cube. All the way through, we needed to make a cube plus a cube, right? I needed to make a cube minus a cube. It has to be a cube plus or minus a cube. I needed to make a cube plus a cube, and then I can use my little factoring formula, okay? Thumbs up? Okay. Okay, turn the page. Now, sure, we'll go through it again, okay? Example 4. So this one is factoring by grouping. By grouping, okay? Girls, you watching? So by grouping, what I'm going to do is put these two, I'm going to group these two together and group these two together. So I do it by grouping, okay? This was different. You got 4 terms. It's not a cube plus a cube. We got 4 terms, right? So we're going to pair them up. It's called by grouping. Okay, so first of all, if we group these two together, what do these two have in common? I want to common factor out what? X squared. Okay, can we take out an x squared, right? So if I take out an x squared, I'd be left with an x plus 5, right? And if you're not sure, you can always just multiply it through x cubed plus 5x squared, right? Go to the next group, the next pair. What do these two pairs have in common?
They can be divided by 4.
Well, they can be divided by 4, yeah, so I can factor out of 4, right? And if I factor out of 4, I'd be left with an x plus 5. Now, what's cool is I see something familiar. I do. And this works. They both have an x plus 5 in common. So if I common factor out, if I pull out an x plus 5 out of both of them, if I pull out the x plus 5 out of both of them, what's left over? X squared plus 4. So I found that they both had an x plus 5 in common. I pulled that out, and what's left over is the x squared plus 4. Okay? So far, so good?
Would that be your answer?
That's your answer. Sometimes they'll try and trick you, and sometimes you can factor it again, okay? Okay, example 5. Nope, am I going too fast? Okay, you guys got it? Okay, example 5, okay? And these are y's. When I was typing this up yesterday, I went y here, and then I wrote x and x. Silly me. Those are y's. I was just, silly me. And I already copied it. I'm like, dang, I'm not going to waste paper. We'll just make it into a y, right? Okay, what do these two have in common? They have a 4y squared, don't they, right? If I take out a 4y squared, what's left inside? 2y plus 1, right? What do these two have in common?
1.
A negative 1. But very good. You're on the right track. How about a negative 1? So if I take out a negative 1, I'm pulling out its negatives. Does that make sense? So I'd have a positive 2y plus 1 because I pulled out its negative, right? Okay, now, do you see something familiar?
2y plus 1.
Yeah, they both have a 2y plus 1. So let's take the 2y plus 1 out of both terms. So if I take it out of both terms, I'll have a 2y plus 1. And I like to cross them out because I know that I've taken them out. I like to cross them out because what's left over? It's really easy to find what's left over. What's left over?
4y squared minus 4.
Now, normally we'd be done. But this is a little bit of a tricky one because you can factor that again. That can be factored again. Can't it? Can't that be factored again?
2y plus 1.
Claire says this could be a 2y plus 1 times a 2y minus 1. And we already have another 2y plus 1 here, don't we? There's your answer.
Can you make that 2y plus 1 squared?
You can. Or we could write a y minus 1 times a 2y plus 1 quantity squared. Yes, Claire, we can. Okay, that's all I have for today. How you like that, huh?